Hello? Hello? Echo. hear me on this? Hey, Murray. How are you doing? Okay, yeah, I'm still trying to get the link set up and everything. So it's going to be on a live stream, but having a little bit of difficulty getting in there. So Hey Murray, I'm working on getting the correct link for it. Uh, this is the Google chat that we're going to have about half an hour before the actual meeting starts at 7 o'clock. Yeah, 6:30. There's usually like a like a social event and everything. Because it's I'm trying to use YouTube streaming to do it, but YouTube streaming only allows chat, so we kind of open this one up just in case anyone want to join and chat before the actual event starts. But let me get you a. Well, let me actually send you a link here. And in fact, if you don't mind, I'm gonna. You're the only one who has this link at the moment, so I'm gonna send this to you. And if you can hit that link and let me know what you see on there, because that's not the link that's in the meetup. Okay. And there's about I think about a 4 to 5 second delay in the YouTube stream versus what you're actually hearing here. Okay. Okay, and what do you see on the screen? You see the introduction to MicroPython slide? Okay. Yeah, and it'll start in approximately 20 minutes or so. Okay. No, sounds good. Thank you, Murray. Thanks, Murray. Hey, Matthew. Hey, Murray. Sorry, Matthew. Hello. Hey, yep, here you good. So this is I'm just trying to get the YouTube live stream going on here. It's starting in about 15 minutes, so I'm just testing some of these things out before we actually get started. Well, it's going to be on YouTube, assuming I can get everything everything working correctly. It's the first time I'm using this software, so it's it is live right now, but it's not exactly as smooth as I'd hope because there's a bit of a delay. But yeah, the YouTube stream is where it's going to be, but there's no voice. It's just it looks like it's only just chat we can use on there, which should be fine. Okay, and that's that link that I just pasted in the chat. I don't know if you can see that, but I'm trying to update the meetup link with the correct info right now. Okay, great. Okay. If you actually can get on that meetup, that's the one I put in the comment, and just let me know what you see on there. Yeah, the one in the meetup comment. Go to that YouTube link. That should be the same one I put in this meetup chat chat here. Okay, all right. And you see the one that says Intro to MicroPython with the meet.google.com address and everything. Okay. Okay, great. All right, and that should be starting up in just a minute. And I'll have to drop from here once that starts up because it's on two different systems. Okay, all right. We can. I mean, if you don't mind, just hanging out for a bit here because I'm actually trying to test a few things on there. So if you actually go on the YouTube one and then I'm gonna put this mic down, and then you can put a few comments in that chat and then in the YouTube chat so I can see if it's coming through and how that flow is gonna work and everything. Okay. Okay, I see your comment there. Awesome. test a couple transitions here with the microscope view. Oops. Alright, so there's about a 5-6 second delay on this. Well, that's good. That's fine. Let's try this. sending a few here. I assume it started. Hopefully the redirect is working correctly. Hello? Okay, give me a moment here while I'm trying to get this set up. Hey, how you been? Hey, Rami. Hey, my video's not quite there yet, so give me a moment, please. Alright, so just a quick FYI. I gave Bill a URL, a meeting URL for the YouTube site for the live stream, that's going to be incorrect because I cannot get the Open Broadcast Studio to stream to that link I sent. So if you go to the link, there's a chat going on there that we can, if you join that one, we should have the meeting started there in just a few minutes. But I'll have to drop from this call to actually take that. But I'll leave the call open, but I'll have to drop the mic from here. Okay. So if you go to the meetup site, and in the comments there's a YouTube link for the new stream site, and that's the one I'll be joining on. Yeah, it's starting at 7, so just not in about just a few minutes it will be starting up. That's it. Yes. Yes. Yeah, it is. It is actually. That's the reason I had to do two. I have two laptops in front of me now, and that's exactly the reason why I had to do that because it was disconcerting to actually hear it. So that's why we'll drop from here and shut the mic off on this one, and then you'll hear it on the other one. Okay. All right, and I'm just checking the previous link that I'd given Bill, which is incorrect. And there are a few people enjoying the chat there, so I'm trying to get everybody to come across to the other one. Possibly, yeah. So. Can you guys see my video? Hey, Bill. Okay. Hello. Hey, Bill. So I sent you I sent you a link that I cannot use for the Flux link. So. Yeah, it is. Yeah, in the chat I sent you another one, which is to the other intro to MicroPython slide on there. So that's my fault. It worked fine yesterday. So, all right. Yep. So, well, what I will have to do, what Rami was saying, is I'll have to drop from this call because there is a significant delay between the live stream and the and this Google Meets chat. All right, and it's kind of difficult to actually have both of them running because I hear my own voice a few seconds delayed. All right, so I'm going to switch over to the YouTube site. So what I'm going to do is I'm going to switch to YouTube, and let me know if that's visible to you guys, and then I'll drop from here. Yep. Yes. Yeah, let's use the YouTube one. The Google Meet is this call right now that we're on, but because of the delay and because of the live stream that I'm trying to do it on, I'm going to use that one. Okay. So I'm going to drop right now. I'll see you guys on the YouTube chat. Hello? Can you everybody hear me? Thank you. Thank you, Matt. All right. Uh, we're starting in just a couple of minutes, and as all things go, this is my first time using this open broadcast studio, so it's a bit clunky. Significant delay, which I mentioned in the Google chat, but hopefully everybody can, you know, hear this fine and see this fine. So what I have right now is I have two laptops going. One of them with the presentation, the other one with the live chat going on the other side there. So I'm kind of, if you see me jumping back and forth, because I'm trying to read the comments as I do this. Okay. So I think the best way is, if you have any comments, just please put it in the chat, and I will, I'll be able to see them. And then if you have any questions, just send it there, and I'll try to answer them as I go through. Okay. And this delay is really, it's like looking at somebody else. Just a quick show of hands. Anybody have experience with Arduino or MicroPython already? All right, another audio check. If you can hear me okay, just put a comment in the, put a message in the comment, please. Great, thanks. Yeah, again, there's a bit of a delay, so I'm reading the chats several seconds later. Anyway, I'm going to get started. If you have any comments, just please leave it in the. If you have anything to say, please leave it in the comments, and I'll be able to see it. But if there's nothing else, I'll start the meeting. I apologize, is that this is my very first live stream on there. I'm using a tool called Open Broadcast Studio, OBS Studio, which is it's brand new to me, so there's some little things I'm learning. The video feed didn't quite work right with two cameras. I have a camera set up for the microphone, set up for the webcam, and one for the microscope to show some of the stuff that I have on my desk here. But both of them didn't work quite properly. Right. So little glitches like that. So I apologize in advance, is that it's going to seem kind of very amateurish at first, but hopefully there's some good content on there that you guys can use. Okay. Just a bit of club administration stuff first. You need your feedback. Let me know how you find this stream. We probably will use a different tool in the next meeting, if it's Zoom, Meetup, whatever it is, depending on how this goes. And if you have any suggestions for some tools or anything else we can use, please let me know, and we can we'll investigate it. All right. Okay. Yeah, Zoom is. I have used Zoom, and we used it for the last one. It was pretty good, and we're just trying different ones on there. I think that people had some questions about Zoom's privacy concerns, security concerns. I will see how that works out. Okay. If there's anything that you'd like to see, please leave comments in the meetup. Send an email to the meetup staff and everything, and Doug, Bill, they've all been, carrying on this meeting and everything. I'm very, very thankful that they're, they every month they put this together. And happy to see that it's one of the oldest groups in Florida, one of the oldest Linux groups in the world actually. So, like to see it keep on going, and then new topics, just please bring them forward. And there's a meetup link. I think everybody here is on the meetup. But if anybody's just joining this that's not on the meetup, please join the Florida Linux user group. All right. Again, I mentioned first streaming talk. Lots of glitches, lots of pauses. I'm getting used to the software, and you hear that. If you hear that in the background, that is my neighbor mowing his lawn right now. You may have real smoke because I do actually have some. If you see behind me, I do have some power units that we'll try to get to. And if I blow something up, well, you'll know. All right. A couple of sites on there that I'm going to post this presentation at my website, and it's also on the Flux site. I don't have everything assembled yet, but this is kind of the raw notes I have on my site there. All right. And it's pretty much going to be any slides. It's going to be the last slide on there, but so be kind. It's going to be a live demo with something that cannot be canned. It's going to be all live with equipment going on here. All right. Telegram group. I do not have a Telegram group. Sorry, Helter. I do not have a Telegram group, but we can probably see about setting one. I'm thinking about setting up maybe besides a meetup, there's something like a Discord app or something we can use. But that's again some administration. We have to figure out how to do it. Okay. Great. All right. So I'm going to switch over now into a. Let's see. Browser, webcam, full screen terminal. Let's see. Full screen terminal. And let me know if you see the screen updated. Okay. So first, I'm going to talk to you a little about what MicroPython is and what ESP8266 is. All right. And 1 second, I'm really trying to get my microscope view here. All right. So we're going to be talking about this. We're going to be talking about this device here. It's one of those people call it Arduino generically for this device. The kind of a bunch of different devices that are these microcontroller boards. They're very small. There are a whole bunch of different types in there. They have that one that you see here. There's this other one here. Behind me, I have hundreds of others. All right, you can see these here. All right, and these devices, they run on these little ARM chips, little Atmel chips. So very, very tiny devices. It has a few K of memory. Sometimes a little bit of flash space, sometimes a little bit of memory. But it's like a full microcontroller. And if you think back, if anybody remembers the 8-bit days, these are actually more powerful than those processors we had back in the 8-bit days, like the Ataris and the Commodores, and even some of the later on versions. They're actually quite powerful, and they cost about this one costs about $2 or so. This one is probably about $3, so you can get them very inexpensively. They're very they're all over the place, and there's a lot of development available. If you search on YouTube, you search on on the internet and everything, there's tons of places that write software and write code. And the thing I want to say is that when I first started playing with these things here, it was kind of like a black box to me. It seemed like, oh, this is kind of it's kind of like this obscure art. And then people were talking about they were developing these microprocessors and everything. It seemed like, oh wow, how do they do that stuff and everything? But once you actually start doing it, you realize it's actually, it's fairly easy to do. And in fact, I would say it's actually easier to code for these things and to work with these things than it is to work on many of these modern processors, because they're just so simple, right? Anyway, so what I'm going to be talking about is how to essentially how to start, start with one of these devices, everything from the setup of your system to the actually writing a bit of code. And I have a couple devices set up on here. It's a little project that I had based on a need that I needed for a soldering fan. And I have this. I don't know if you can see it here. Well, you can't see it. I'll show it to you in a little while. But I have a soldering fan behind me. And there's something I wanted to automate that. So this is the prototype I'm doing to actually set it up here. Okay. Let me go back to this one here. All right. So again, here's one of the fans. All right. That's the problem with that is that I'm kind of forgetful, and I have a lot of junk going on. I have a lot of things going on all the time, and I wanted to make a little device that instead of having to turn it on like I did just then, have it automatically go on. So I rigged together a bunch of sensors. It's actually a simple sensor here. Let me show you this one. This is the sensor unit on here. It's an MQ135 sensor unit. I forget which one that one is, but it's a very simple hookup. All right, and then anytime it detects smoke or anytime it detects anything like high levels of carbon dioxide, carbon monoxide, you can use it to actually turn on the sensor. All right, to turn on the fan using this relay here. All right, and it's a very simple setup. Okay. All right. So to get started, what I'm going to show you is actually the first step. I have a link. I'm going to show you my browser. I have a GitHub page that you're welcome to clone it. If you go to my website, www.digitalhermit.com/ I think it's electronics, I have this presentation up on there, and inside there's a GitHub link. And let me show you the GitHub link. Let me know what you see on the screen. Alright. So all this is available in this my GitHub link on there. If you scroll down into Linux, Arduino, MicroPython, if you clone the repo, then you can clone the entire repo, and the entire presentation, all the code I have inside this presentation's in here. Probably the most useful one for me is going to be this make file that I'm going to walk through here. And the make file, it's like all the tools I use to actually get started with it and to set up the environment and do everything here. Okay. So I'm actually going to start by cloning this repo here. And I do already have a clone. I'm just going to drop it into a new place, clone it, clone my repo, copy it here. Then I'm going to go into a shell. Alright, let me send that over. I'm going to my shell. If you go on GitHub, just search on Kwan Lowe, KWANLOWE. I'll post that link. I'll post that link later. Alright. So, I'm inside a shell right now, and let me just actually put this out here. Alright. I'm going to go into a source directory. I'm going to make a temp directory here. Alright, and I'm just going to clone the repo. Well, if I had it, I'll clone it. 1 second. Alright, so I'm going to clone my entire repo on here, and it's just a few items inside of it. Alright, inside this I have a directory with my code. Alright, now when I tinker with these things, I always set up a makefile first, because again I'm kind of forgetful. So I drop all my commands that I use throughout the session inside a makefile. A lot of times I'll use Ansible or something else for the setup, but makefile is very easy to use. Everybody understands it. So I can easily get started. The main one, I'm going to actually first run this make setup command here. Let me show you. I'm going to run make, and if you hit tab a couple times on there, if you have bash autocomplete loaded, you'll be able to autocomplete. I'm just doing make setup. Make setup actually just does a few things. It creates a Python virtual environment for myself. All right. Uh, I like to do this because I'm working on different projects all the time, and each project sometimes requires a different set of packages for Python packages, and because of that, they tend to conflict with each other. So I like to have it so I can generate a requirements txt and everything, so I can always reproduce that. So depending on how you work, some people like to have what's one big Python repo and drop everything in there. I like to separate them out. All right. So this first make setup command I did, it just pretty much it creates this Python p36vn environment. All right. It adds a couple packages to it. You can see here it installs pip install esp tool. All right. Um, and pretty much that's the start of it. All right. All right. Now with that ESP tool, it lets you run other things on there. It lets you program the board. All right. Now I actually have this board here. Let me show you. Set up. Let's see if I can do this. Let me know if you see that on the screen fine. Okay. So I have the ESP8266 board connected via USB cable into my laptop, right? And you can't see that here, maybe you can, but it's connected to my laptop. All right. With the ESP tool now, I can now program the board. All right. So a couple things first. When you attach that ESP8266, it shows up as a USB device. So don't worry about that. I'm going to unplug it. I'm going to plug it back in again. Alright, now I run dmessage. You see that that device is available now. Alright, and if I look inside dev, alright, you see that new device is available here. So to make this work, the main thing you want to make sure that your user is in this dial out group. If you're not in the dial out group, you have to do everything as sudo, which you generally don't want to do. Alright, so inside the make command, there's another utility that I created. Well, utility. It just runs a command add user group. So you want to do is make add user group. All right. And what that'll do, it'll just add your user to the dial out group. And depending on what version, what Linux distribution you're running, and this may be slightly different for you, but pretty much that's what you're going to have to do. If you do that, you're going to have to log out, log back in, and then once you do that, you can verify that you're in the right group. All right. In this case, it shows that I'm in the dial out group. So I have access to create that to that USB device. All right. We need a couple other tools on here. You see the next one is this install minicom. All right. So I can do a sudo install minicom. Make install minicom. All right, and that'll just run that sudo. It'll run minicom. It'll say it's already installed. All right. Go through it. I'm running on CentOS box right now. And just give me a quick audio check on here. Make sure everybody hears me okay, please. Can you guys still hear me? I see the chat's a bit quiet right now. Okay, great. Thank you. All right, so I installed Minicom. We'll need Minicom because this device shows up as a terminal device. It's kind of like talking to a modem. In fact, you can actually use modem commands to talk to some of these chipsets on here. So install Minicom so we can we can actually run ad hoc commands on it. All right. Now the next thing to do is that it's a firmware. Now, essentially, this is if you ever use a Raspberry Pi, sometimes you have to install an OS. Installing the firmware is very similar to doing that. You want to install, in this case, the firmware that I'm installing is the MicroPython firmware. And if you look on my make file here, you see this download firmware. You don't see the mouse moving, but let me see if I can change that so you can actually see. 1 second. I'm going to modify this. And I'll put hide mouse no. Sorry about all. This is it doesn't look like I can hide my mouse. I can show my mouse. All right. So I have this download firmware. Pretty much, it just goes to the website, the micropython.org websites, and it grabs this firmware version. All right, that I set up here. There are different firmware versions. The one I'm using is from 2019. The newer ones are unstable releases, and they have a bit more features and everything. Actually, I do use the newer ones more often, but I didn't want anything to change, so I just used the 2019 version, which is stable. Okay, you do see the mouse. Great, great. Okay. Anyway, so next thing is this make download firmware, and what that'll do, it'll go out, it'll grab the firmware from that site, right? So at this point, it's pretty easy. I mean, everything is kind of scripted at this point. If you go online, it'll show you all these same things. Go to this website, download the firmware, and then a couple other steps you have to do is Xthings to actually erase the flash on there. Okay. Oh, even in full screen view. Okay, sorry, Rami, I see that it's not. Let me see if I can change that. This is the glitches of working with a live demo. All right. Hopefully that's a bit better. Okay. All right. So next thing I do is I actually deploy is download the firmware. To actually make these boards work, you have to actually deploy we do two things. We erase the existing flash on there. You can get by with not erasing it, but there's some kind of glitches occur on there, so it's always a good idea to erase flash first. All right. And the command that you'd use on that case is this. I'm using this ESP tool command, which is installed as part of my build. And then inside this virtual environment, and I'm specifying the port where I define it, and then I'm just running this command erase flash on there, the ESP tool erase flash. All right, so it's just in a make file. So I'm actually going to run make erase flash on there, and I'm going to switch the view so that you can actually see what happens as it kicks off. Let's see if I can do this microscope plus terminal transition. Okay. So as I do this, what you should see is you should see a bunch of stuff happening. Oh, I got an error on here. Let's see what my error is. 1 second. Okay, I'm getting a serial device error. No data, disconnected, or multiple. Okay, so I think it's because I have two different things running on here. Let's try this again. I'm just going to reattach it. I'm going to try this again. Okay. I always mention live demos. All right. Let's do some troubleshooting. Make sure that we have the right port. Okay. Let's see if this will help. Do you see that now? Okay, let me know if you see that. I'm going to give it a few seconds. Let me know if you see that. If you see the errors on there. Alright, I'm going to look at the errors that we're seeing here. Some kind of serial port traceback. Okay, so let's see what's going on here. I think what probably happened is that Yep. I was actually in Minicom. Right. Rami, do you see it any better now? All right. I adjusted the screen. Hopefully that's a little bit better. I think next time what I'll do is I'll fix the screen proportions. I think what may have happened is I full screen the video. I full screen my terminal, so that kind of dropped it off there. Okay. Um, what you should see now is you should see I just put a clear screen on there. I changed a couple things on there. I'm gonna have to try to maybe re let me do this. I think I know what's happening. Let me try to grab that screen again. Okay, let's try this. Full screen terminal. Alright, let me know if you see this better. And again, sorry, because of the significant delay. Alright, hopefully you see that now. Alright. The problem I had is that I actually had my Minicom running at the same time, so all those errors you saw is because I had Minicom running. Better before? Same as before? Okay. What I did was I switched it. On my terminal I do see that the screen has finally cleared, so because of the delay you're probably just seeing it as I'm saying this. Alright, and I'm going to actually wait for your feedback. Only the traceback is visible still. Okay. Let's see. Okay, you see the cleared screen. Okay, so pretty much what I did, it's gonna flip back as I switch it over. Pretty much what I done, because I had Minicom running on in the other terminal, it was taken over the port, so I couldn't actually run. I couldn't do the erase flash. But now that I do have it Minicom turned off, I'm going to show you this one here. Hopefully you'll be able to see this. So you'll see both of them. Right? I'm going to do a make erase flash now. And what should happen is it should blink, and then you should see it starting to reset the flash. Alright. Now it's completed. Alright. So going back to my make file, I just did the make erase flash on there. Right. The next one I have is the make deploy firmware. And in the previous step we'd actually download the firmware. We're going to go ahead and deploy it right now. Alright. And that's a quick step. Actually, let me clear the screen so it'll make it easier. Okay. And this is just going to go ahead and drop into the upload the MicroPython binary to this board. Right. And just do a quick audio check again here. Make sure what you see is correct, that you actually see the flashing going on. This shouldn't take long. It takes about a minute or so to run. Okay, so I don't know what to do about the delay. Let me see if maybe I can try changing my streaming settings. Let's see. Yeah, it looks like I can't change the streaming settings and kind of in mid-flight. Okay. All right. Thanks, Rami. Um, so, all right. So the board should have just completed. Hopefully you see that. It does look a bit fuzzy, but hopefully it gets a bit better. All right. So what we've done right now is actually we've just uploaded the MicroPython firmware over to the board. All right. Next thing we need to do is actually set it up. We're actually going to configure the wireless. I'm going to configure a few things on there. Now, there are a couple ways to do this. All right. Let me drop into another one here. All right. So, hopefully you see this next one. I'm actually going to start at Minicom right now in another terminal. All right. And then in a moment you should be able to see a command prompt on there. All right. Okay. So this is a Minicom session on here. This is connected directly to the board. And what you have right now is actually a Python environment on there. So you could, for example, do something like run a Python command. Okay. You print Python, right? There's a tool on here. It's called the web REPL, which is a read. It's essentially a Python read execute, loop. So there's a tool on here called web REPL setup. All right, and if you run this, it'll ask you to enable or disable the web REPL from running on boot. Now this works really nice because you saw just a moment ago is that I could not program the board while I have Minicom running, so I kind of had to flip between Minicom and flip between program the board and Minicom. I'm kind of used to it, so I do it very quickly. But you can also use this thing called web REPL, which is a it's like it's a web version of the REPL loop, REPL loop, which is the main Python read execute tool. All right. So if you log into the board with Minicom, you can just start this import web REPL setup. All right. And I'm going to say I'm going to enable it. All right. You need to set a password, so I'm going to set a password for it, Flux Demo. All right. Confirm the password. All right. And changes will be activated after reboot. Would you like to reboot now? Yes. And then the board will reboot. All right. Now what that does is actually it resets the board, and it also enables it so that you can program the board. All right. Now that's done. We're actually all ready to start. But the problem is when this ESP, the two modes you can do it. You can either set it as a client to your network, which is not the default, or you can set it as an access point on there. Now, if you set it as an access point, you actually have to, if you're on Wi-Fi, you have to disconnect from your Wi-Fi and then go ahead, attach to the ESP8266 board, then configure it and everything, which is kind of a pain. So what I generally prefer to do is actually have it configure it so that it comes up automatically on my network. And to do that, we need to use another tool. We go back into our our makefile that we created, and we actually run a setup utility. Now, I'm going to show you the setup utility. Let me exit from here, all right, and I'm going to drop into the makefile again, and hopefully everything will pop up. All right, the delay looks a bit better now that I'm in a smaller screen. All right, so I'm going to look at the makefile again. All right, download firmware, start Minicom, clone web REPL, push code. Now, if you look inside this directory, what you'll see here is that I have a couple things on here. There's one called a boot.py template. All right, I'm going to show you this one here. When this board starts up, the first thing it runs is this boot.py. All right, so anything you can put your setup code inside the boot.py. In this case, what I've done is I've set it up with my network SSID and my network password on there. So what you do is when you're ready to actually to work with this board, you just go ahead and modify this template, copy it to boot.py. So instead of calling boot.py template, just call it boot.py. Set your network, your SSID and password, and then you can deploy the boot.py. Now I'm not sure boot.py because it actually has my network credentials in there. Nothing, there's no big secret. I actually changed it before I started this demo, but I don't want to. As a general safety thing, I don't want to show that on there. But pretty much it's identical to this with these two things changed, all right? And you see the only thing it does, it imports the web REPL library. sets up this do connect this do connect function that pretty much just sets up the network. You know, just runs up some Python code that sets up the network, runs that function, and then starts the web REPL tool. Right. So once you've done with that, I have inside the make file here. I'll show you the make file again. There's one called push code, and if you look at this push code segment here, it uses a tool to copy the boot.py. It uses a program called rshell, which I probably don't have installed here. I might not have put it inside the setup, but it's going to install rshell. Let me see if it's installed. If it's not there, I'm just going to install it right now. Oh, sorry. Let me make sure if I had it set up here. Nope, I don't have it set up. So I'm going to change this. I'm just going to run setup again. I'll check that in a moment. I might not have done that. Oh. Writing on the fly. So, all right. So I'm going to install the rshell utility. Sorry, I didn't install it before. Install the rshell utility, which is going to use to actually program the board now. All right. So I'm going to do the make push code. All right. And all that's going to do is actually going to copy my, and it's going to fail right now because I have it's not running. I'm going to run push code, which is going to try to connect to the USB device, which right now is in use by Minicom. So as soon as it fails, I'll go into Minicom, break it out, and then run it again. All right. So while that's going on, let me break into Minicom, exit from Minicom here. Just break out of here and then just rerun it. Okay. This time it runs fine. I'm going to change this here. I'm just going to run it again so you can see actually what's happening on the board. Do you see that any clearer? The video view. Unfortunately, I cannot actually see the video as I live, but here you go. All right, I'm going to do a push code again, and hopefully you see a little bit of noise on the board as it launches it. Okay. All right. Okay, almost done. All right. So all that's done is that once you do that, it pushes this boot.py over to the board. All right. And that's simple enough. All right, and let's go ahead and see if we can restart the board. So there's a little reset switch on here. Let me see. I'm going to change to a webcam view. Okay. All right. If you look on this board here, there's a little reset switch right here. All right. So I'm going to go ahead and just pop this reset switch. A couple ways you can do it, but I just popped the reset switch. And it started. Now you see it started blinking is because part of my push code here is I have a... Alright, let me show you here. Part of this push code, you see I'm copying two files. I'm copying the boot.py, which is that startup code. I'm also copying this main.py. I kind of dropped them into both of them. You don't see that's because you only see this screen here. I'm going to show you here. All right. Part of the push code that I ran, it copies the boot.py, which is a setup code, and this also main.py, which I'm actually going to talk to you right now to show you what that does. All right, and that copies it to this directory on the board, which is PyBoard. When it runs, the R shell uses this PyBoard as a place where all the code is stored. And we're actually going to use that just a moment and show you how that works. All right. So pretty much I copied the code on here. I copied one bit of code, which is boot.py, sets up my network. Next is the main.py, which is the code to, and I'll show you that now, which is this code here. Okay. So this is my main.py, which I also copied. And it's again just Python code. Import a couple libraries, machine and time. All right. I define this other function toggle that pretty much just whatever the state of that pin is, I'm going to change it to something else. All right. I set a couple of variables for readability, and I'll show you what those. Okay. I mentioned I'll talk about this pollution threshold. These sensors return a value, and I'm going to explain this in just a moment. These sensors return a value between I think it's between 0 and 1023. All right. Anything above this, I want to kick off a a warning. All right. Now, each of these LEDs that you let's see if you see this. You see these LEDs that are flashing on here. All right. Those are tied to pins. If you look on the side of these here, there's a bunch of pins associated with it here. Each of these are different pins. These are accessible as you can actually just call them, refer to them by their pin numbers. All right, which is what I've done here. So the LED 1 is machine pin 2. LED 2 machine pin 16, or GPS, we'll call GPIO 16. I have a relay that's attached. That relay is associated with pin 5. All right, and if you look at, there's a little trace running here. All right, the relay, this trace runs here, and this goes to that particular pin that's actually associated with pin 5. Now they're not necessarily in order, but there is a chart. If you go to the schematic for this, it'll show you where those pins are actually linked up to. And I have this sensor here. Okay, this sensor here, all right, it's also attached to the A0, to one of the pins on there. You'll see there's a pin on there called, this wire attaches the A0 pin. All right, so it's a really, talk about a basic circuit. This is as basic as you can get. It's really just a relay and a sensor. That relay is controlled by one pin. The sensor feeds data onto another pin. All right, and the code, what I have here, just reads that. All right, so like many types of microcontrollers, you go through, it's called an event loop. It's just a loop that you just loop continuously through. So when you boot this system, it just keeps on looping through this bit of code on here. All right, so while it's running, it's going to do this. It's going to print the sensor reading, all right, from sensor.read. So sensor.read is just that machine pin, that pin 0. All right, it's going to read it, print it. Now, if the sensor reading is above my pollution threshold, all right, it's going to enable the fan. By enabling the fan, all it's doing is it's going to set this pin LED2, this pin to turn it on, all right, and turn on the relay. So I'm not turning on the relay now because, well, let's do this. I don't have power set up on here, but let's go ahead and turn on the relays. It may or may not work. We'll see. All right, and I'm going to do a make push code here. Okay, and I'm going to reboot it by pressing the reset on here. Okay. Now, what's happening is that it's going through the loop, and it's pretty much just flashing this code back and forth, right? Okay. All right. Now, let me see. You guys still see? Not in focus still? Is it still out of focus? Okay, sorry. I was actually showing you the solder fan instead of the main.py. So this is the main.py. This is the code that's actually running on it right now. So solder.py. Right. So you see, all it's doing is just toggling those pins on and off. That's why it's flashing. So my apologies. I was editing the wrong code because I was setting this up at like 2 o'clock last night. But this is the code that's running. You see, all they're doing is toggling the pin on and off. Toggles a pin, sleeps for 500 milliseconds, and then it shuts off. Right. But I actually have the real reason I wanted to actually do this demo was to show you this relay setup here. All right. So right now what we're doing is flashing the pins. But let's look at the solder. fan. Okay, which is this one here. We're actually looking at the solder fan, and we're actually going to push this code now because I pushed the wrong bit of code. I'm going to push the right code this time. It's called, I have it set up as push fan. So go ahead, I'm going to do make push fan, which is going to push my fan code here. Alright. And hopefully you'll see it run. Alright. And as it runs, you'll see the board will stop flashing. Alright. And then it'll reset. It won't reset, I'll have to reset it manually. Alright. So I'm going to reset it. Alright. Okay. Now, I don't know if you can see that. Alright, you probably can't. But I'm going to do one thing. I have to change this slightly. Alright. Hey, bear with me 1 second. I have to actually go get a power supply from another room. I'm going to be back in about a minute, okay? So please hang on one quick second. Okay, I'm back. So, what I'm going to show you here is this. Alright. Now, this ESP82, I'm actually drawing power from the USB, which is kind of okay, but what I'm going to be doing is I'm going to be drawing this from a fan. The fan is not going to be able to be driven by the USB. So I have here, it's a breadboard power supply. Alright. And all this is, you can actually select different power. You can look on, I don't have a close-up of this here, but it pretty much just attaches to this breadboard right here. Oh, dang it. The pins are all busted up on this one here. Let's see if I can get this attached. There we go. Okay, so this it gives me a bit more current on this one, so I can actually power this and the fan at the same time. But just for giggles, we'll try it. Right. Now you see the LED here. This LED is lit up. Okay, so the point of this here, this code is actually doing, it's going to read the sensor, and if the threshold is over a certain amount, it's actually going to kick off the relay. All right. So to demonstrate this, I'm actually going to drop into Minicom again. All right, let's start Minicom up. All right, let's see, reboot this. Okay, now you see what's happening? It's going through the sensor, and it's seeing that it's incorrect, so it's going to be turning on this relay, because right now the sensor is reading too high, right? But after a while, what happened, because I was actually having my hand around it and everything, it's probably reading some stuff in the air and everything like that. But after a while, it'll slowly drop down to a proper threshold, and it should be about 500 or so that I've tested. 500 is the the average. That's clean air essentially. So whatever reason, if I pass out right now, is because right now it's still hovering about 550. To make this a bit more interesting, let's change this. We're going to change the code here. I'm going to change the setting to, let's say 600. Let's set our threshold to 600. Okay. Restart it and start Minicom again. reboot it. Okay. Now what you should start seeing on there is the threshold. Okay. I think my code might not have gotten pushed. All right. Let's see. This is always the the thing with debugging on pollution threshold is 600. Sensor reading above threshold. Okay. Sorry. Okay. I'll make sure that I'm writing the right one here. And again, I am not exited out of Minicom, so I cannot do that. So let's restart it. Control C, push it again, and let it start up. Okay. Reboot it. Okay, and let's drop back into Minicom again. For whatever reason, it doesn't look like the code is being pushed. I think maybe because I have this high. We're going to try it again. Restarted it. If you're in the REPL and you exit, it'll just reboot the board. Right. So for whatever reason, it's not looking like it's picking up the right code. So I'm going to drop into the REPL shell. So again, this is one of these live demos. Sometimes you see all these little problems that pop up. Now, one of the things that you may notice is that the Arduino is kind of like an open standard on here. So even though I have one of these particular boards in place right now, because there are many manufacturers on there, there's sometimes slight differences in how they operate. So even though they're very cheap, you know, $2-3, what a time some manufacturers do, they'll substitute a part in there. Sometimes it's usually like the UART. UART is the universal asynchronous receiver transmitter, which is essentially your serial device on there. So every once in a while they'll swap in like a cheaper part, and by specs it looks like it's fully compatible, but every once in a while there are these glitches between it. In this case, what you see, there's a glitch on here where something is not quite running as expected, and that may be because I'm in Minicom. Let's try this again. All right, I'm going to run it. Okay, so I'm in R shell now. All right, so what I did just now is I ran this R shell utility, which is an easier way of actually going directly on, so I can actually troubleshoot to see what's on here. All right, so if I do an ls, I'm actually on the board right now. So what you see is actually on the board. I'm actually running commands on the board. All right. It stores all the user configuration in this directory called PyBoard, and depending on the type of board you have, this path may be a little different. For these particular devices, it's under /PyBoard. All right, and if you look on here, you can actually run a Unix commands on there. So I have 3 commands. There's that main.py. I have that webrepl config.py. All right, if I cat webrepl config.py out, all right, you see that that's the password that it configured itself as. All right. And if I cat the main.py, All right. We can see, okay, you see my sensor pollution threshold, it hadn't changed on there, which is one of the reasons why, that it's not being updated. And there's probably some glitches that I made, maybe because the board isn't in the, I didn't flash the board and then run it, so maybe there's something it's holding onto it. So in this case, what I generally do is I'd go ahead and erase the flash and then just run it clean again. And again, it's everything is in a make file, so it's relatively easy to do. But that's one of the glitches that you'll see. This particular board I have here is, again, it's a clone. It's not actually a true Arduino. So again, there's probably some kind of glitch. Matthew, as I see, I do use it for home automation, and what this particular one I'm doing here is just to turn on and off a sensor for a soldering fan. And let me go over to this webcam again so you can see what I'm doing. All right. So I have this soldering fan here that when it's kind of a pain because this, sometimes I wear gloves when I'm soldering. So it's kind of a pain sometimes, and I can, I don't know, it's not really, I don't think it's a really good design. But this soldering project is actually to just mount a sensor right in front of it here. So whenever that detects that there is bad air, it'll automatically turn this on. And that's pretty simple. I'm going to, the relay, it's going to drop right inside here. So I'm going to drop the relay inside here and have the relay just turn on, move this on and off switch. Just toggle this on and off switch. That's all it does. Right? So that's one thing. But that's a simple project. That's not really home automation. But yes, you can use it for home automation. You can, many ways you can do that. You can use either just MicroPython. You can, talk to a web service, actually set up as a web service on there. A lot of tutorials online. I have some code on there. I don't have it on that link, but I'll add some code on there that lets you do things like control your if you want to control like cameras or something, Arduino cameras, or control, some other device, but you can certainly do that with MicroPython on there. Okay. Mike, I wanted to show you that one, but I also wanted to show you some of the other kind of boards that are available out here. And let me move this across here. So, Matthew, what you're talking about is this is another project I'm working on. This is also another sensor. This is actually a kind of a burglar alarm sensor I'm setting up here. A similar type. It's a similar footprint for that same sensor I was showing. This is a motion detection switch here. If you see this one here, this is a motion detector. Pretty much anytime there's vibration, it causes it trips this. It trips this little sensor on here, right? So this is like a burglar alarm, configuration I'm using. It will be solar powered because it's going to be mounted outside, and it'll talk over Wi-Fi to be able to, to send details back, camera and other details. So you can buy one of these cameras, like one of the Weiss cameras for about $20 or so. They're not very expensive, but this gives you a lot more control over it. You can do, if you don't not say trust, but if you don't feel comfortable with having somebody else have your data, it's one of those things where you can actually just run it, set up a cloud server somewhere. You can stream this data directly into it very easily, and it just shows some data, and you can play around with. Okay. So as question as far as Raspberry Pi, I do use Raspberry Pis. Let me see if I have that. Okay, so I do have a lot of Raspberry Pis. Actually, I buy them in, not say bulk, but I buy them in these lots for about 6 or 7 of them for about $50, which is a lot cheaper than buying them on spot pricing, just a single unit on there. So the main difference between the Raspberry Pi and the Arduino is Raspberry Pi is probably about $15 to $20 a pop, sometimes a bit more. Depending on if you can get them. Right now, because of the COVID crisis, a lot of the pricing for Raspberry Pis went up significantly. Talking about from it was $20, now it's like $35, $40 for some of these here, which to me there's not really a lot on these things. It's a very good. I'm very big fan of them, but there's just not a lot on there. In fact, I pull apart once in a while. I pull these apart, and take out things. You can actually get cheaper ones. I can get the Raspberry Zero and so forth. Which are a lot more expensive, but even the cheaper ones, it's still a lot more expensive than than any of the Arduinos. The Atmel the chipset on here. You know, some of these here I buy them in bulk, maybe 20 or 30 at a time, and it's $2 to $3 a pop. So when you say 20, you know, I'm buying them in bulk, it's, you know, $50. I get a whole bunch of them on there. Yes, you can edit the threshold value in our show. Um, the particular device I have is actually it's very limited, and actually the same point Matthew is making is that I like to buy hardware just enough, just the point where it's just enough to do what I want, and then no more than that. So for something like this, I'm actually, even though I'm prototyping on this particular device here, the actual device I'll use is even smaller. Let me see if I have one here. Okay. So what I'm actually doing it is on this device here. Let me see if you can see that. Oh, there we go. All right. So it's even smaller. These are about $1 a piece. 99 cents a buck a piece. You can get them. All right. So this is that same. Oh, it's actually underneath here. Yeah. So this has everything on there. It's also Wi-Fi enabled, but you see that it doesn't even have it doesn't have a USB header, for example. And for this particular application, you don't need USB, you don't need anything like that. So these are 99 cents a pop. So if I'm building something, I'll build it on here. All right. Yeah, I'm actually going to edit. I'm going to edit this R shell. I want to troubleshoot why it's not. Oh, I can't have this. Okay, let me do it from here. I think I know what happened. You know what actually happened here and why it wasn't editing, because I just cloned this repo. The other VI session I had was in another directory. So yeah, I'm dumb. But actually the reason I did that was to show that what I like to do is make sure I can rebuild that development environment very quickly. So just by cloning it, I'm able to get started working on it. I can do everything else from within that shell. I don't like setting up the environment to the point where it's custom, that's super customized, so that I can't reproduce it, because I tend to jump from project to project often. And if I didn't do this, what happened is that I'd have to relearn it every time. So I try to make it so that as much as possible, everything I build is into the code, so I can reproduce it. All right. So I'm going to go ahead and push this now. Hopefully it'll work. And then what you should see. Let me see if you can see this here. Okay, it completed. I'm going to reset the board. Ah, dang it. Okay. All right. So what you see here, there's a sensor here. I rigged this. I also attached the LED sensor to the sensor to the LED. So when the relay triggers, so will the LED on this board here. So I'm going to do something where, let's see if this will work. I have a bottle of alcohol, all right, and I'm going to spray right next to it here. And hopefully that'll generate some, okay, you see? So I sprayed alcohol near it. It generated a bunch of fumes. The fumes then turned on the circuit, all right? So what I'm going to do next is, let's show this. Let's start Minicom again. And we'll just look at it, all right? So you see the sensor reading right now. It's 900, very high. And hopefully it'll start coming down as the clears away. All right, so you start seeing it come down. At some point, it'll once that alcohol evaporates, it'll drop down to the point where the sensor itself stops. Okay, and I'll give it a few more seconds. Oh, it's probably gonna take a minute or so. But what I'll do is I'm gonna move it away from there a bit. I shouldn't have sprayed it right there. Okay, it's dropping. and then we can actually watch it drop. And then when it drops to below 600, what should happen is it should just turn off. Let me see if I can get some fan. So let me turn on the fan near it. Okay, it's dropping, and hopefully not too much longer it'll get to the point where it's below that threshold. And once it does that, it's almost there. Give it a few more seconds. And then once it does that, you should see it just click off. Okay, and the fan clicked off once it reached that threshold. All right. So anyway, that's hopefully that's that's kind of an introduction to it. I don't really have much else to say about it. I think we're at the hour time now. But any questions or so that just put in the chat. I'll keep the chat open for a bit longer. Feel free to ask me any questions. Again, the website stuff is on there. All this code is on the website. The make file and everything on there. Feel free to ping me on Meetup or here, wherever it is, and I can answer any questions you may have. All right. I did want to show and let me show you all this also here, while this is going on. Transition here. Okay. So I do a lot of the stuff I like doing outside of the work related stuff, Linux stuff. A lot of electronic stuff. Create a ton of little gadgets. The project I'm actually working on is a Mars rover project, so I'm trying to recreate a Mars rover scale version, but build all the sensor arrays, build everything inside of it, and then have it running around the yard, around even around the city, collecting data and sending it back. So that's kind of a project. It's probably about 30% of the way in. So a lot of 3D printed pieces, a lot of other devices on there. But I'm always tinkering with this stuff here, and it's kind of like this, especially with this COVID stuff. This is how I'm relaxing right now. I just building all sorts of stuff. So, got a whole lab and everything set up here. Have a lot of fun here. Anyway, really thanks everyone for joining. I really apologize about the glitches we had. Very new to Open Broadcast Studio and some of this, but hopefully it wasn't too onerous. And hopefully we get to do a live one again soon, and we'll do that. Okay. So, thanks very much, everybody. Again, I'll keep it open for a bit.